Hello, friends. This is Nalini Rajagovindan from Vaira Citadel. In this video, a problem statement in hypothesis testing is given, and question follow the statement for which you have to give the right answer. You are advised to go through my previous video on hypothesis testing before trying to solve the problem. Yes, all set, ready. Here goes. Now, study this example. A school in metropolitan city wants to check the temperature of students randomly during the COVID period to allow them attending a class or to send them back home. The temperature threshold is determined as 98.6 degree Fahrenheit, and any student having temperature above 98.6 degrees is sent back home, and students with 98 or 6 degree Fahrenheit or lesser is allowed to enter the classes. I hope you got an idea about the study. Since it is practically not possible to test all the 4,000 students studying in the school, students are randomly selected for testing the temperature. All right. Now answer these MCQs. There are 4 questions given and try to answer them on your own. Then refer to the solutions for verification. Okay. The first question says, what are the consequences of type 1 error in this scenario? The choices given are A. Sending students back home when they have fever. B. Not sending students back home when they do not have fever. And choice C is sending students back home when they do not have fever. And the last option D is not sending students back home when they have fever. Now select the correct answer. And now the second question goes like this. What are the consequences of type 2 error in this scenario? Same scenario. Choice A, sending students back home when they have fever. B, not sending students back home when they do not have fever. C, sending students back home when they do not have fever. D, not sending students back home when they have fever. Now select the correct answer. And question number 3. With reference to safety, which error has got more serious consequences in the given scenario? Option A, type 1 error. Option B, type 2 error. Question number 4. What significance level should the school use to reduce the probability of the more serious error occurring? Option A, 0.01. B, 0.05. Option C, 0.10. And option D, 0.005. And so here goes the correct answers. Question number 1, C. The option C is the correct one. And for question number 2, it is D. And for question number 3, it is B. And for 4, it is C. Now, we will see the explanation for all the 4 questions. Now, first and foremost, write down the null hypothesis and alternate hypothesis for the given statement. Remember, null hypothesis is always the normal routine thing happening. And the alternate hypothesis is the challenge or the new claim. So in this scenario, what will be our null hypothesis? That is, all the students are either having the temperature of 98.6 degree Fahrenheit or below. There is no fever. Nobody is having fever. That is our null hypothesis. Because 98.6 degree Fahrenheit is the normal body temperature. And anything 98.6, anything below that. Some people have hypothermia, the lower temperature. So that is null hypothesis. And what will be the alternate hypothesis? Anything above 98.6 degree Fahrenheit. So our NA, A is for alternate hypothesis. It says anything greater than 98.6 degree Fahrenheit. That is, the students are having fever. So the first thing you should do is to write down the null hypothesis and the corresponding alternate hypothesis. And null hypothesis is always the routine thing. Here the routine thing is normal. Everybody is running the normal temperature. And the alternate hypothesis will be some claim, new claim. That means some of the people are having running temperature, so we should not allow them into the classroom. That is the new claim. So that becomes the alternate hypothesis. All right. Now, having written the null hypothesis and alternative hypothesis, what next? Now we have to see what are the possible outcomes from this procedure in the school. Now, how do we do it? We can simply write the 4 possible outcomes, or you can even draw the checkerboard like we did, with the row heading as the decision taken and the column heading as the in reality what happens to the hypothesis, whether it is true or false. So you can draw it or just simply write the 4 possible outcomes. What are they? The first possible outcome is the sending students back home when they have fever. So they have fever, you are sending them back home, not allowing them to attend classes. So this is a correct decision. So no problem. And what will be the second decision? Not sending students back home, allow them to attend the classes when they do not have fever, when they do not run any temperature. This is also a correct decision, isn't it? So we can be safe. And now look at the third alternative. I mean, what we have given is ABC. So sending students back home when they do not have fever. So they are not having temperature, but you are sending your radar, your thermometer is faulty, and you are sending them home, but they do not have fever. This is a wrong decision, and it is a type 1 error or alpha error. How do we know that? Because here we are rejecting the null hypothesis when it is true. What is null hypothesis? No fever, normal temperature. But you say you are rejecting the null hypothesis. It's true. The boy is not having fever. It is true. But you are rejecting it and sending the boy home. So that is error, and this type of error is called type 1 error. So the answer for question number 1, what is the consequence of type 1 error happening, is the answer third, C. Sending students, what will be the result? What will happen? You are going to send the students back home when they do not have any temperature. So this is type 1 error. And what is the other question? Second question is, what is the type 2 error? What is the consequence of type 2 error? See here the fourth option, D option. Not sending students back home, allowing them to attend classes when they have fever. So they are having fever. The whole purpose of this operation is to find out the temperature, and if they have fever, send them back home, allow them to not to mix up with the other children so that the children are not exposed to the virus. So that is the whole idea behind your procedure. But now what we are doing, we are sending back students home. We are not sending them back home, allowing them to attend classes when they have fever. So this is also a mistake, error, because of our decision making is wrong. So this type of error is called type 2 error. What is it? Not rejecting the null hypothesis when it is false. So our Null hypothesis is false here. That he doesn't have fever is false here. He is having fever. But you are not sending him back home. So you are not rejecting the null hypothesis. So this is a type 2 error. And this is the answer for your question number 2. What says that what is the consequence of the type 2 error occurring? So D will be the answer because fourth one is A, B, C, D. So option D is the answer for question number 2. Did you get this so far? Good. Now, what is question number 3? What is the question 3 says? It says which is more dangerous? Type 1 error or type 2 error? So the answer is type 2 error will be more dangerous in this case because what is type 2 error? That is, we are allowing students having temperature to mix up with other children, thus exposing them to the threat of COVID. So option B is the answer for question number 3, which is more serious. Because this type 2 error is more serious than type 1 error. What is the type 1 error? That we are sending home students who are not having temperature. Doesn't matter. Only the parents will come objecting to it. Why did you send my child back home? He's all right. He's not having temperature. He missed his class. He missed his drawing class. He missed his PT class. So that we can manage. That is not very serious. But if you allow the children who have got temperature to attend the classes, they will mix up with the other children, thus exposing them to the dangers of the COVID virus. So type 2 error is more dangerous than type 1 error occurring. So the correct answer is the choice B for question number 3. And for the question number 4, the answer is C. Let us see. What is the fourth question? It asks, what is the level of significance? What level of alpha will the school keep in order to prevent this more dangerous type 2 error from occurring? What will be your the chosen alpha level? So, by keeping the alpha level as high as 0.10 of all the options, 4 options given, 0.1 is the highest number. See, look at the other thing is one is 0.05, other one is 0.01, the other one is 0.005, and highest number is 0.10. So if you are going to keep the alpha level this much high to the highest number, that will increase the probability of type 1 error occurring. That is, you are going to send more students back home when they are all right, when they are not having temperature. Doesn't matter. This is not going to affect very much. But the type 2 error will be decreased. If you increase the alpha level, the chances of type 1 error will go high. What is type 1 error? You are going to send back students who are all right. That is okay. But the probability of type 2 error will be lessened, because if type 1 error increases, the type 2 error will decrease. So what we want here is the type 2 error to be decreased, because type 2 error is more dangerous. So by keeping the alpha level the highest of all the possibilities, here A, B, C, D option, it is the option D. I think 0.10 is option D, if I remember correct. You go and check it, but the correct answer is 0.10. Never mind whether it is C or D, but I remember it is being D. So by keeping the alpha level as high as 0.10, we are increasing the probability of type 1 error to occur more, but decreasing the probability of type 2 error, which is more dangerous in this case, in this scenario. Remember that in this context. So friends, I'm sorry. The answer for question number 4 is C. not a D, as I have told you, because the value is correct, 0.1, which is the highest number, but that highest number is given in the option C, not in the D. So for question number 4, option number C is correct because it has got the highest value of alpha, 0.110, right? So you have seen in that example. So there is always a trade-off in fixing the alpha level, and which should be done in advance before testing the hypothesis. Remember, not after testing. So you have to fix the level of alpha, the level of significance before testing the hypothesis. So your null hypothesis, alternate hypothesis should be chosen with care and thought, and you should think of what are the errors that could creep in, what are the consequences of this error, type 1 error and type 2 error, which is more dangerous, which one you want to minimize. Suppose it is type 1 error you want to minimize, choose that as the null hypothesis and keep the alpha level very low, so that will reduce type 1 error and increase the type 2 error. But suppose your type 2 error is more serious, then keep the alpha at the highest level so that type 1 error will be increased but type 2 error will be reduced. See, so they are corresponding. If you increase the chances of type 1 error to happen more, then the chances of type 2 error will be reduced. And if you reduce the chances of type 1 error to occur, if you minimize it, then type 2 will occur. The chances of type 2 error occurring will be more. So always the level of significance should be chosen with care, thought, and reason to minimize any serious error in decision making. So this is also called as decision rule or the test of hypothesis. Well, this is all about hypothesis testing in this video. I'll be making more videos on one-tailed, two-tailed hypothesis testing sooner. If you like this video, please subscribe to Vaira Citadel and click the bell icon to receive notifications about my publications. Until then, bye-bye.